Hi class. I wanted to make this video talking about z-score distribution. I actually already have a live video describing z-score distribution. And again, for this course, I highly recommend going through the PowerPoint slides and the audio. And these videos are meant to supplement that audio. So I do talk a lot about more in depth about certain things, and they're all very important concepts. But these videos are meant to sort of supplement that other audio sort of content. So I wanted to go through introduction for standard normal distribution, and this slide is slide 6 in my slide deck for lecture 5 z-scores. And what I wanted to sort of build up to was this idea that raw scores from two different distributions can be compared using z-scores. So by understanding standard normal distribution, I was hoping that we could also understand why raw scores from two different distributions can be compared using z-scores. Okay, so I'm just going to start out by drawing out the standard normal distribution. And there's certain characteristics about standard normal distribution. I'm just going to point out a few. So I'm going to just draw it out. And this is very sloppy, of course. So the main thing to point out is that it's bell-shaped, curved, right? So at the peak here, the mean, this is where the bulk of samples fall, right? And this is characterized by mu, which is the mean. So we learned about central tendency in the last few lectures. So this, where the bulk of samples fall, that is the mean. And for a standard normal distribution, the mean falls at the bulk of the distribution, and then as it goes down this way, you can see that there's less and less scores as you go further right. And as you go further left, there are also less and less scores as you go further left, right? So what I'm talking about is how many scores fall underneath this distribution here, right? As you go more and more to the right, to the middle, right, it gets higher and higher. Whereas at the tail ends, there's a lot less scores that are falling with underneath this curve. Okay, so what I want to talk about is that we have so as we've been talking throughout the course, through the semester, we have what are called raw scores, right? So I'm just going to show you. So a raw score, just for example, let's just say we have our mean, which is 75, right? So I just made this up, right? So we have a 75, so this is X, or raw scores. And this corresponds to the mean. So for this imaginary distribution, we have a mean of 75, and I'll just say my standard deviation, or sigma, will be 10 for this population. Okay, so I just made that up. So as we go one standard deviation over, so this is one standard deviation, we'll have an 85 here. If we go one standard deviation to the left, we'll have a 65. Okay? So this is what that looks like, right? So then we want to sort of correspond that. So what's known about standard normal distribution? And this is in the slide again, is that our z-score for the mean is 0. So that's known. When we go one standard deviation over to the left, our z-score will be 1. So these are z-scores. And do you see how this corresponds to the raw score? Okay, then we go, if we go 1 standard deviation to the left, then we'll have a -1. Okay, so please note that this is a -1. And this is +1 if we go to the right. So a few things to note about this. The first thing to note is that we are going 1 standard deviation to the left and we get the -1, and we go 1 standard deviation to the right and we get the +1. This is corresponding to our sample where if we go 1 standard deviation to the right, we have 85 corresponding to the 1. And if we go 1 standard deviation to the left, we get 65, which is corresponding to -1. Okay? And this is also corresponding to our distribution. So what this is, this is in the slide, but what is being shown in the slide is that within this distribution, and this is what's known about standard normal distribution, is that when you go 1 standard deviation below the mean or 1 standard deviation above the mean, it is known the proportion of points that fall underneath the curve here. So we know it is known based on standard deviation, on standard normal distribution, that, and this is in my slide again, that 65%, 68% of the data falls 1 standard deviation above the mean and 1 standard deviation above the mean, okay? And then if we go even further, so if we go 2 standard deviations, right? So +2, right? Because these are 2 standard deviations, and then -2. So again, another standard deviation. Then what proportion of points fall within that? Up here, let's see, let me erase this. What falls here is also known by standard normal distribution, and that is 95% of our data is falling from +2, z-score of +2 to -2 z-score, right? And that corresponds with our raw scores, which would be 95 here and 55 here. Okay, so then we could even go up to 3 standard deviations. And I guess I didn't draw this very, what is it called? Very like, very proportionately, because, okay, so it'll fall here. So this is 3. And this would be, fall here, -3. Right? And so this is another standard deviation, right? So when you move between points, you're going 1 standard deviation, right? So we're going +3 standard deviation in this direction to the right, and then -3 standard deviation to the left. And we know that 99.7% of the data falls within from +3 z-score to -3. So I'm not expecting you to memorize what proportion falls, but what I want you to know is that a particular amount, a particular proportion, a no proportion falls between these z-scores. and the distribution, right? So, and then what I really want to note here is that our raw scores for this particular population corresponds to particular z-scores. And the same would be true for another population. So let's say our mean turned out to be 75 instead, and our standard deviation was still 10. We would still be able to map this population onto z-scores, and then we could use the z-scores from this population. So this would be population number 2, to compare it to our original population number 1. And that is because we can convert our raw scores and our standard deviation into z-scores. And so the z-scores are what are standardized. They're standardized in the sense that they are standardized based on standard deviation for that particular population, so that we can know, once we convert to z-scores, we know, right, what proportion will fall underneath the curve for a +1 z-score and a -1 z-score, right? And then we can find a raw score and say, oh, if it falls within this first sort of segment for +1, or we can say it falls within where it falls within the z-score distribution, and then we can compare it to, once we convert our raw score to z-score, we can compare it to another population if we convert that population to z-scores as well. So again, I just want to say that in this video, I aim to give you an introduction to standard normal distribution. And what I try to show you is that within standard normal distribution, you have your raw scores, right, that can be converted to z-scores. And those z-scores have specific distributions underneath the curve, or it shows what proportion or what amount of data shows up underneath the curve, can help us compare that population, a particular population, to another one if we convert both populations to z-scores, because z-scores are standardized based on standard deviation. And so we're able, once you standardize a population to a z-score, you're able to compare them. Because if you just compare, let's say you compare, let's say, even in my example, oh wait, I made the same exact, sorry about that. So let's say our example was actually not 75, but like, let's say it was a mean of 85, right? So if someone gets a mean of 85 in population number 2, they're going to be right at the mean. But if you look at population number 1, so this original 75, and if you got an 85, you're actually 1 standard deviation above the mean in this population number 1. Whereas if you got an 85 in population number 2, you would be at the mean, right? Because that's the mean. So hopefully this makes sense. Please feel free to write in the discussion and on Canvas if you still have questions about this, and I'll try to address specific questions regarding the standard normal population. The standard normal distribution.